So, you have a good weekend? Yeah? Ready for this weekend?
Yeah, I want this. I'm ready for state.
Yeah? Plus, in just a day and 23 hours, we'll be in the 40s.
Wait, what?
We'll be in the 40s.
Oh, 5 minutes temperature.
Yeah, I did too.
Oh, well, we were in the 40s this morning.
Put all of our team logos on the back.
I can't find my phone.
I'll actually buy it. Y'all just have to buy it on like all Monday.
All right, hey guys, so I want to run through, I know you're sitting with them in front of you. If you want to grade yourself real quickly, I'll run through the evens. So 2 is C, 4 is B, 6 is E, 8 is B, 10 is A, 12 is D, 14 is C, 16 is C, 18 is C, 20 is B, 22 E, 24 A, 26 A, 28 D, 30 D, 32 C, 34 C, 36 A, 38 A, 40 B, 42 B, 44 C, 46 A, 48 C, 50 A. So, if you have a question and want to talk about the evens, let me know and we'll take a look. Anything you missed?
How do you take it?
State test. All right, so number 50. All right, again, probability is probably not going to be our strongest suit since we haven't covered probability. But hopefully we will by the end of the year, although it will not do you any good on this Saturday. So, So real quickly, if you're looking at number 50, it says for a particular weighted die, probabilities of rolling 1, 2, 3, 4, 5, and 6 are in the ratio 1, 1, 2, 3, 5, 8. So what that means is, I don't want to get you messed up on this. What it means is the probability is not going to be 1 out of 2. I'm sorry, the probability is not going to be 1/6 each time you roll the die. The probability is going to have this weird ratio. Now, one thing that you might know about ratios are what we use when we do odds. Okay, so like if I were to say the odds, and odds is different than probability. Okay. If I were to say the ratio is 1 to 2, that Baylor wins tonight in the championship game, then that doesn't mean they have a 1/2 chance of winning. It means for every 1 win, there's going to be 2 losses, which would kind of represent 3 total outcomes, right? So if the odds were 1 to 2, we say the probability is 1/3 that they would win. If the odds is 1 to 1, we say that's 1 win for every loss. So that's 1 win for every 2 outcomes. They have a 1/2 chance. If I said something like 1 to 8, 1 to 8 would mean they have a 1/9 chance. Does that make sense? If I said something like 3 to 5, 3 to 5 would mean they have 3 wins. If I said that was the odds of winning, 3 wins, 5 losses, that's 8 outcomes. That would be a 3/8 probability of winning. So on this particular thing, and I got to be honest with you, I don't know that I've ever seen ratios written like that ever before. Okay, I always see ratios written like this. So even I probably, and I don't really remember exactly, but my guess is I had to go back and rethink what that meant. But if on this particular one you had 1, 1, 2, 3, 5, 8. So on this particular odds, which was 1, 1, 2, 3, 5, 8, That was saying those are the odds of each particular number coming up. Like the number 1, the number 2, the number 3, the number 4, the number 5, and the number 6. So this was basically, it's a weird way of writing it. I haven't seen it like this, but this was saying out of a total of, 13, 16, out of a total of 20 outcomes, this is how many times each one of these numbers will come up. So that means that the probability of getting the number 1 would be 1 out of the total of 20. The probability of getting the number 2 would be 1 out of the total of 20. Probability of a 3 would be 2 out of 20, which is a 10th. Probability of getting a 4, 3 out of 20. 5 would be 5 out of 20, which would be a 4th. And a 6 would be 8 out of 20, which would be 2/5. And if you add all those up, it ends up being equal to 1 out of 20 out of 20, which is 1. It's like 100%. So that's a weird way of saying this, but that's what that means. And I honestly had never seen that before. I honestly don't even remember seeing it until this again. So anyway, if that's the case, it says, what's the probability that in a single roll you'll roll an odd number? Well, what does odd mean? And I want you to think about what you're saying back to me. What does odd mean?
Not divisible, or it's not evenly divisible, but.
Okay, that's true. I'm asking a bad question. What are the odd numbers?
1, 3, 5.
Say it in a sentence.
The odd numbers are 1, 3, and 5.
I'm trying to get you somewhere. That is a true statement also.
Isaac, what?
What I'm looking for is this. The odd numbers could be, I mean, if you roll a die and get an odd number, it can't be a 1, a 3, and a 5, can it? Like if I roll the die, am I going to get a 1, a 3, and a 5 when it shows up? What am I going to get? A 1, a 3, or a 5. Are y'all hearing that? So I can't get all 3 in one roll, right? I can't go, oh, look, I got a 1, a 3, and a 5 in one roll. So on this particular one, if I'm trying to find the probability, I can succeed with either a 1, which is a 1 out of 20. I can succeed with a 3, which is a 1 out of 10. Or I can succeed with, and you remember back to Miss Tyree or Miss Coley, when you learned probability, if you're ever doing this and that, you multiplied. But if you're ever doing this or that, you added them. So even though you answered great answers to my poorly worded questions, what I meant was to say, if I roll that die, what could happen? I could get a 1, I could get a 3, or I could get a 5. So what you end up wanting to do here is actually add the 1 over 20, the 2 over 20, and the 5 over 20 to get an 8 over 20, which reduces to 2/5. So I think, yeah, it was 2/5. Does that make sense? But that's a weird way to write odds. Normally they'll say 1 to 8. So 1 to 8, what's a 1 win, 8 losses? So there's a 1/9 probability. This was saying the probabilities are in the ratio. Oh, I guess they wrote it where it looked like odds, but they said the probabilities are 1, 2, 3, 4, 5, and 6. No, I'm sorry, or 1, 1, 2, 3, 5, 8. So I guess that's just a really weird way of saying that, hey, 1 and 2 and 3 and 4 and 5 and 6 have these successes if you roll a total, if you add it all over 20. Again, I've taught probability, read a lot about probability, taken it in college. I've not seen ratios written like that for a problem like this. I don't have any recollection of that. Anyway, yeah, with me, we're not going to talk about that. And I mean, we might say something like, hey, we've got this weighted die that's kind of funny. And I'll say, hey, the probability of getting a 1 is 1 out of 20. Probability of getting a 6 is 2 out of 5. I might give you information like that and then say, what's the probability that I get an odd number if I roll one die? And then you would say, oh, well, I could get that, or or that, and you'd add them together because it's an or statement. But I have no, whatever. I'm just repeating myself at this point. That's unusual to me. What else you got?
36.
36. So 36 said, let f be a piecewise function. Have we talked at all, this is kind of a weird thing, but have we talked at all about piecewise functions? Seems like, yeah, very little, if anything. Okay, I think the first piecewise function I really introduced you to was the absolute value. You remember how absolute value is a V? The absolute value graph, right? But what it really means is the absolute value function is really two pieces. It is a piece of y equals x, which looks like that, and it's a piece of y equals negative x that looks like that. But it's only going to be y equals x on this domain when x is positive or 0, and it's only going to be y equals negative x on this domain. Now I'm just giving you a random example, so I just keep it there, and that's what gives us the v. It's a piecewise function. Now, this particular function says, if this is a piecewise function, then the function f of x is either even, odd, or neither. Now, what does even mean? You learned some stuff about even.
Y-axis symmetry.
It has y-axis symmetry. So let me ask you a question. Couldn't you sketch this? Now, I know it's a little bit of a stretch since you haven't learned much, and I'll show you the way I did it, but like everybody I talked to in this is actually on the comprehensive test as well. A couple of the algebra 2 problems are chosen to be on the comprehensive test. A couple of the geometry ones are chosen. Then they fill in the rest with like 30 other ones. So this was one of like the 7 or 10 or whatever on your test that was also on the comprehensive test. So one way to do it is just to graph this. I think you can graph these. So let's think about the graph. If I have a graph right here, and I said, what does y equals x cubed look like? What's the x cubed graph? It's that one, right? And what is negative x cubed then? It just does that, right? So here's your negative x cubed. I'm just going to draw a little fatter than normal. Now, where does negative x cubed exist? To what? To the left of negative 2? So basically, you're going to come in here at negative, I'll tell you what. You're going to come in here at negative 1, negative 2, and you're going to go up there, and at negative 2, you get negative 2 cubed, which is negative 8, negated. So you're up here at, if this curve just keeps going, you're up here at 8, and you're only going to keep that part of the graph. Everything else goes away. In fact, you're not even going to keep it at negative 2 because it doesn't equal there. All right? Now, what else can you graph? Can you graph x squared plus 4? What's x squared? Parabola, up 4, plus 4 means up 4 because it's on the outside, right? It's not like x plus 4 on the inside of the square. So I could go up 1, 2, 3, 4, right? And graph a parabola. Now, I'm going to graph the parabola from what to what? Negative 2 to 2. So why don't I plug negative 2 in there and see where that takes me? And then I can mark those points and just sketch my parabola. Plug in a negative 2 in there and I get what? 8. Oh, that's convenient. Negative 2, I'm up here at 8. I already know I'm right there at 4. What does positive 2 give me? Also 8. So I'm up here. So I can sketch that parabola. Are you with me? And then finally, what does this look like? That's just a regular old x cubed graph. Where do you start it? I mean, normally we start it right here, right? But it's going to do something like this and something like this, but we only want it from where? Greater than 2. So let's plug a 2 in and see what happens. If I plug a 2 in there, I get what? 8. So this thing went up like this and then like that. Well, what kind of function is this? Even or odd or neither? It'd have to be even because it has y-axis symmetry. So that's one way you could do is just graph it and look at it and do your symmetry test. You tracking with me? Now the other way to do it is much uglier, but let me just show you. The definition of even is this. And you might remember this. That's the definition of even. And you know what it means? It means opposite values of x give me or make y values, f of x's, equal. So my y's are equal even if x's are not. Now think about that. Even if x's are opposite. Now think about that. That means 1 and 1, same y value. 2 and 2, same y value. 3 and 3, same y value. What does that give me? Y-axis symmetry. Now watch this. If I were to plug a negative x everywhere, and I mean everywhere here, check it out. I'm going to show you over here. If I plug a negative x in, I get negative x cubed, negative x less than negative 2. I get negative x squared plus 4, negative 2 less than or equal to negative x less than or equal to 2. And I get negative x cubed, negative x greater than 2. Now let's clean it up. What is negative x cubed? Answer that question. What is negative x cubed? Negative x cubed? Negate it. X cubed. Okay, so I'm going to change this to x cubed, simplify it. What's negative x quantity squared? X squared. So I'm going to change that to x squared. What's negative x quantity cubed? Negative x cubed. So I'm going to clean that up. What do I do with negative x less than negative 2 to make it an x? I want to have just the x by itself. So what would I do? And if I divide by negative, what do I have to do? Flip the inequality. So I'm going to divide by negative and flip the inequality. I'm going to do that here. Change the sign, change the sign, change the sign, flip the inequality. And I'm going to do that here. Change the sign, flip the inequality. Now, isn't this, think about it, isn't this the same as the original? Look at that. X cubed when it's bigger than 2. Negative x cubed when it's smaller. And isn't smaller than 2 but bigger than negative 2 the same thing as this? So wasn't f of x the same as f of negative x? Now, what if it's not the same? What if it's totally opposite? Then it's odd. And what if it's just weirdly different? Then it's neither. But graphing, it's such an easier way to go than I think probably this. And I was in teacher mode, so what I did was just the algebra of it. But most of my students in comprehensive, they went, we just sketched the graph and it had y-axis symmetry. I'm like, why didn't I think of that? So anyway, for whatever that's worth. What else? 48. So 48 asked, for how many values of x will that expression simplify to an integer? All right, another question that was on the comprehensive test. So you're asking good questions that are hard, okay? So what makes an integer? Pretend for a moment it wants to know how many values of x. Like, for instance, if x is 1, would that be an integer? If x is 2, would that be an integer? Well, to me, that's really hard to look at because your x values go forever, don't they? I keep going higher and higher and higher, and I'd have to check every value of x on the planet. So then I started thinking creatively. I thought, well, rather than check every value on the planet, or at the very least, at least through, it says there are infinitely many was one of the answers for D, so that's not comforting to me that I would have to check that many. So I would have to check until I at least found 12, because 12 is an option, or 13 to know that it was more than 12. But again, it could also just be none of these. So that was really ugly to me. So then I thought, wait a minute, how do I normally check if something's an integer? How would I check if a fraction was an integer? So you would just divide it, right? Like if I said is 24/12 an integer, you go, oh yeah, because 12 goes into 24 2 times with no remainder. Well, why don't I just divide then x plus 5 into x squared plus 25 and look at the remainder part? Now, at first glance, you might go, what in the world? Take a look at it. So on 48, if I divide x plus 5 into x squared plus 0x plus 25, And I could use synthetic division also, right? I could divide -5 into 1, 0, 25. So if you like synthetic division, that works. Sorry. 1, 0, 25, -5, 1. Okay, yeah, 50. Okay. So what I end up with is positive x minus 5 plus 50 over the divisor. Now, this is why this is easier. Now I can look at it and say, what values of x make the remainder what? Yeah, a whole number. Are you with me on that? Because if I have a value of x like 3, I get 3 minus 5 plus 58. 58 is not is a fraction, right? So that sum isn't an integer. I'm rewriting my fraction in a different way. And by rewriting this fraction as this, now I don't have to check every number in the world. There are only so many numbers that go into 50. As soon as x gets to be 46, you know those fractions are going to be fractions forever, aren't they? And to me, it's pretty easy to check this. Like I can check 0. When x is 0, it works. Now, does it say positive integer? What does it say? For how many integral values? So I can check, I checked all the possible numbers that would go into 50 evenly. Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 25, and plus or minus 50. Those are the only ones that divide into it, right? So of all those numbers, plus or minus 1 through all plus or minus 50, that's what x plus 5 could be. Does that make sense? Like x plus 5 could be plus or minus 1, right? If it's positive 1, does that make sense? Divided into 50. Yeah, if x, look at it, if x plus 5 is positive 1, then x is, wait a minute, that doesn't make sense. Plus or minus 1, 2, 5, 10, 25, and 50. Oh, right. So if x is -4, -4 plus 5 is 1, and I get a nice whole number. Are you with me on that? If x was equal to -1, and I subtract 5, x would be a -6. So if x is -6, 50 over -1 is -50. That makes an integer. Are y'all seeing this? So basically, all of those values, which would have divided into 50, all of those could be x plus 5, which means if each one of these could be x plus 5, then you're going to get that many individual x's. And since there were 12 of those numbers, I could say that there are 12 of them. Does that make sense? Now, otherwise, you could guess, check, and revise, but you would have to check literally all of the integers from +1 through +45, and then from -1 to -45. You'd have to check all of those, which is a lot of guessing and checking. This kind of limits it a little bit because when you divide, you can just look at that remainder. That remainder of the divisor and make sure that's a whole number. Because remember, it didn't have to be a 0 like normal. It would just have to be some integer because you're adding it back to another integer expression. And you end up with an integer. So just kind of some number theory thrown at you. I don't know that that really falls under anything you've seen before, but the math involved is something you probably understand, the long and synthetic division. So another good question. What else?
46.
46. Okay, so it says if x squared minus 5x plus 6 is negative, then the value of that takes on all values. Then the value y takes on all values in what interval? Number 46. What did I do here? So first thing I did is I looked at this part and said, if it's negative, and I found out, I wanted to know where that thing was negative. Okay, and now we've done this before. So I probably started this problem playing around because if I'm looking at it after having already done it and going, what am I doing? I probably had to spend some time staring at this for a second. So the first thing I did is said, how do you find out where a polynomial is negative? We've done this in class, actually on a test too. What do? How do you find out where it's equal to 0? You factor it and solve. So can I find out where it's negative by factoring and solving and finding out where it's 0? And then what do we do once we find out where it's 0? Y'all remember doing this, guys? If I have a number that's less than 0, if I want to know where it's less than 0, I factor it and I solve where it is either equal or in this case not equal because there's no equal sign. I find where it's not equal, and then what do? I check on either side of these numbers and see what's true. And when I check the number in between 2 and 3, like 2.5, I got a positive number here and a negative number here, and a plus times a negative is a negative. Are a negative smaller than 0? Yes. So I knew that this part was going to be less than 0 there. Now, the question was, for 46, if that's less than 0, then what is x squared plus 5x plus 6? Then that particular thing takes on all values in what interval? So here's what I did. I tried to take this particular function and make it equal to that one by being a little creative. So right here, the only way to make this a negative 5x was to subtract 10x from that number. And you can see that it's now a negative 5x. Now, unfortunately, I can't randomly go around subtracting a 10x unless I add a 10x to it. So I did that as well. Now, once I did that, what do I know about this? What do I know about that first part right here? This is really a tricky question. I'm trying to put both. It says it takes on all the values on what interval? Once I've done this, I know that this answer is what? For every value of x between 2 and 3, that's going to be negative, right? We already know that it's less than 0. So I plugged in 2 and I plugged in 3 because I know that this is going to be negative from 2 to 3. So if I plug 2 into this, that part equal to 0, but then that part's 20. If I plug 3 in there, that part's equal to 0, but that part's equal to 30. So it stands that every number in between that 2 and that 3 are going to spit out numbers in between 20 and 30. And I don't even, honestly, that's me playing around and trying to be overly clever. That's pretty tough. It's got to be a better way to do this. Let me see. If that's negative,
Plug the 2 and the 3 in and select that. X squared plus 5x plus 6.
yeah, part of me doesn't even know why you need that. X squared plus 5x plus 6. This factors into that, which means it looks something like this. It says it takes on all values if that's less than 0, then the value of y takes on all values in that interval from 20 to 30. It's just a weird question. I gotta be totally honest with you. I'm staring that up. I got it right, but I'm just looking at it wondering, I don't even know what I even thought of to do this at this point. Maybe I'm losing brain cells.
Well, you know how x is like between the 2 and the 3?
Yes.
And can't you just plug in like 2 for x and y equals x squared plus 5x plus 6 and then plug in 3 and then you get 20?
Yeah, you totally can. I really, that's what I'm saying. I really don't even know why I'm doing this. Because you're right, you can just solve for that 2 and 3, plug the 2 in there, plug the 3 in there, and get 20 to 30. Maybe that's why I'm looking at this going, why on earth would I try to do this? So I guess all they're asking, really, this isn't as bad as I thought. Anybody else get this? You got it, Lily? No, what I get this is saying is, if these x values are true here, what y values do they spit out here? And yeah, I honestly don't know why I did all of this. It really isn't necessary. All you got to do is look at f of 2, which is 20, and f of 3, which is 30. So if your answers here, these are your answers between 2 and 3, they're going to spit out answers between 20 and 30, or y values between 20 and 30. I don't know why I'm doing this. Like I was hallucinating. Yeah. I don't think you need to be all that tricky. Fine, solve this, plug it in there. But I'm still looking at it and thinking it's just kind of, yeah. What else you got? Yeah, that's a terrible one. Get rid of that right here.
For number 6, were you just supposed to like set it equal to A plus BI?
Give me 2 seconds. For number what?
Number 6.
Number 6. Yeah, I hate that answer. That was terrible. All right. Number 6 said, I'm looking at that just, I think we've done these in class actually, or did for our homework. Yeah. Do you remember, I don't know if we've talked about these already yet, but do you remember we took our conic sections test and I sent you home to read this section on solving systems? And you came back the next day and we talked about it real briefly and you worked on it in class and asked questions and then we took a 40-point quiz over systems. Okay, and in that packet, there was a little problem like this where I was asking you to take a square root of an imaginary number or a square root of a square rooted number already. So here's the thing you got to know about this. If I ever take an a plus bi, a number like that, and I square it, I'm going to get another or a different, I'll call this a1, b1, a different a plus bi. You just do. Same thing here. If I ever take an x plus y root, I'll call it a, and you square it, you are going to get another number if you square this, x2 plus y2 root a. It's going to happen. So with that in mind, doesn't it make sense that I could take one of these, which have already been squared, and square root it and get back to the original? Does that make sense? That's the thinking you have to have on these problems. So what I do is I just take whatever they give me, the imaginary number, and I go, all right, this, if I square root it, is going to give me another a plus bi number. I have no idea what it is, but it is going to give me that. So here's what happens. If it's going to give me an a plus bi, you can see that right here. I'm just going to square both sides and see if I can solve for what it is. So I just write this out and I put a square on that and a square on that. Now the square on the square root makes the square go away. But when I square this, I have to actually like do the whole squaring thing where I square the first, square the last. But when you square the last, you get b squared I squared, which is negative b squared. And then you get that times 2. There's my middle term. Okay, so I have this statement now. Now let me ask you a question. If I wrote this statement out, doesn't it seem logical that if this is true, that the stuff over here that has an I in it would have to be equal to the stuff over here that has an I in it? So I make an equation out of that. And when I do, the i's conveniently cancel, as they always do. I can even divide by 2, and I get an equation that represents a and b. Are y'all with me on this? Because this is one of the easier problems, the more common problems that show up, and we can all do this. Okay? Then the next thing I do is take what doesn't have an I in it. That part, and that part, and I make a second equation. Well, guys, now you have a system of equations. Just solve it. Or take my advice and don't solve it, and 99 times out of 100, at one time in 28 years, have I seen a problem like this where the answers aren't whole numbers. So rather than solve it and use an ugly quadratic formula, all that junk, rather than do all that work, what are the only numbers that can multiply to give me a 15 and write them all out? Now you got to be careful, because it could be 15 and 1, 1 and 15, negative 15 and negative 1, negative 1 and negative 15. It could be 3 and 5 or 5 and 3, right? 5, negative 3, negative 5, negative 5, negative 3. So write them all out, and then just plug those numbers in here. But here's a little trick when it comes to plugging them in. If I'm going to plug a number there and there for A and B and get a positive, what do you know about A? It would be bigger. Well, I can cancel out anything where the A is smaller. And then I could just kind of go in there and go, well, it's not 15 and 1, because that's like 225 minus 1. Let me get rid of those. 5 and 3 work nicely. 25 minus 9 is 16. 25 minus 9 is 16. So those are my two what? A and B's. So if those are the two numbers that can be A and B, take these and plug them back in, because I'm solving for this. So my answers are 5 plus 3i and negative 5 minus 3i. And the question said A and the B have to be positive, so you go with this one. That was in the question. Normally you just write both of them out because they both work. Y'all seeing that? That's not uncommon. I mean, that problem shows up a good bit. We can do that. When there are a lot of these things that you look at and you're like, I don't even know what they're asking. But that's something we've covered. We got to be getting that as a class, honestly. I mean, careless errors happen, but like we need to know how to do that kind of stuff. What else? 10 says, so for a general quadratic, the sum of the roots is negative b over a. We've been talking about that, right? And the product of the roots is c over a. And it's c over a as long as the highest power is an even power. Otherwise, it's negative c over a. But the sum of the roots is always negative b over a. It says a particular quadratic function for a and b and c added together is negative 6 and has the sum of its roots equal to negative 0.5 and the product of its roots equal to negative 2. Find the absolute value, the square root of the absolute value of ABC. So what basically am I giving you in this problem?
Some of its roots and the product of its roots.
And some other random little equation, right? So aren't I just giving you a system of equations? So look, all I'm doing is giving you 3 equations. I'm just finding a nice long way to tell you that. They basically said that a plus b plus c is negative 6. The sum of the roots is negative 0.5 or negative 0.5. The product of the roots is negative 2. So I cross multiplied on both of these or did the slide rule to get a system, but I just need to solve. So once I got those 3 equations written down, I just decided to solve. Now I got to find all 3 variables. So it looks like I solved for b here, which is a over 2. And I plugged that in for b, a over 2. And then I solved for c here and got negative 2a. I plugged that in there. And I did that so I could get the whole equation in terms of a and solve for a. And then once I had a, I plugged a in there to get my b. And I plugged a in there to get my c. And then I multiplied them together, took the absolute value, and square rooted. And I got to be honest with you, I probably didn't multiply them together because I don't want to actually have to square root a huge number. So right there, couldn't you just say, okay, absolute value is going to make that positive, and then what can I start pulling out of here? Is it square root, right? Or even better, isn't that 24, which is true, yes, but isn't that a 2 times a 12? So I could take a 12 out, and then I have a 6 left over, which is a couple more 2s with 1 3 left under. So 24 root 3. Is that right? Yeah.
Yeah, I got the system. I think I just did like a careless error.
Well, good. I mean, listen, that's going to happen. I mean, I don't care if you missed something because you knew the math, but you made a careless error. I mean, that's frustrating for you. But at least you learned it and it's in there floating around. But yeah, they just made it really wordy. Anybody restart reading that and go, oh, man, assume the position? You can't do that. Yeah, I mean, I appreciate your honesty, but don't do that. Just read through it. Don't assume it's ugly. I mean, it might very well might be ugly, but just plug your way through it and see what happens. What else? I'm guessing not everybody got them all right, so there's bound to be a question or two out there.
Number 32.
32. Palindrome. So even if you don't know what a palindrome is, they just told you, right? So palindrome is a number that reads the same for, like if you flip the order, it still looks the same. And the question is, how many palindromes are between 10,000 and 99,999? Now that seems a lot harder than it is. This is 32. Inclusive. Okay, so here's what I did. I mean, at first glance, you're like, really? I got to look at every single number. I'll never get this done. But then you start thinking, wait a minute. If I start with 10,000, clearly 10,000 is not a palindrome, right? But if it's 10,000, if I'm starting with this, all I got to do is change that 0 to a 1 to get the first one, right? Now, if you're going from 1 through 99999, I decided to just look at the 1s, then the 2s, then the 3s, because I figure the same pattern is going to occur in each one, except instead of starting with 1 and ending with 1, I'll start with 2 and end with 2, start with 3, end with 3. So I really thought, well, I could have a 0, 0 there. I could have a 1, 1 there, a 2, 2 there, 3, 3 there, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. So when I looked at this, I thought, oh, there are 1, 2, 3, 4, 5, 6. I'm sorry, there's that one right there. But then there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different options, right? And on each of these 9 options, what could I have? 10 different options. But on each of these 10 options, what could occur right here? Any number between what? 0 and 9. So if this could occur, but also any other number between, we've already counted 0, so 1 through 9, that's a total of 10 options for each of these, isn't it? So that means 10 times 10, there are 100 options starting with 1s. What do you think that means for the ones that are the 2s? Right? So I've already written that one, right? So for the 2s, there's also 100, right? And for the 3s, there's also 100. So for each of the numbers 1 through 9, you've got 100 different options you could do. And I didn't have to write out all 900 options if I'm just thinking about that cleverly. So you end up having 900. And you could do counting principles with this too. You could say something like, all right, for the first and the last, there are how many options from 1 to 9? There are what? You could have 1, 2, 3, 4, 5, 6, 7, 9. There are 9 options here. And then for these two spaces, how many options are there? 10 options. And then for that space, how many are there? 10 options. And you would learn the fundamental counting principle says, if you can do this, if you have to make that choice and that choice and that choice, you just multiply those 3 together. So that's a much more efficient way to do it. But if you haven't learned counting principles and stuff like that, thinking this way might be a little bit more practical, just to visually see it. But you know these two have to match 9 different ways because 1 through 9. Those have to match 0 through 9. That has to match. That has to be a number between 0 through 9. What else? Anybody? that better. Two minutes. Anybody? All right, might do something different tomorrow. Shake it up a little bit. Sensing fatigue. State tournament test fatigue. Hey, knock that homework out. The homework is what? We're doing the G odds.
Is this the last one?
This is the last one. G odds for tomorrow. All right. Let's see what we can do. It's our last test, and then we're going to start something new on Thursday and on Friday, so we can try to finish this year, getting everything in. And remember, guys, hey, we're going to be at the school on Saturday here at 8:30. Okay? If there was anybody I talked to about taking it early, and you're going to do that, I think there were one or two people, you have to meet in Helmer's room at 7 a.m. But you need to talk to me first because he has limited room. And it has to be something like an approved kind of substitution. But he's going to get you in there at 7, try to start at 7:15, and then get you out as early as possible. But the two tests have to overlap. If that, I don't know. You can ask me why if you care later.
I missed the first day. So. Yeah, you have to know about this.
Say, can you customize the shows better than that? Yeah, I'll
I was talking to
do cotton ones with dry cotton with wet.
but you can eat
Yeah, and, wait, you want cotton?
Oh, we're good.
Yeah.
Okay. I can do like any type, like you'll be able to pick your type.
Steve. See you guys. What's up, man? Hey, how are you?
Okay, how are you?
Not too bad.
Your hair looks
I'm
good.
sorry. Oh.
From yesterday.
Translation.
But I was about to say, what happened yesterday? I can barely.
So hard.
Wait, is that in your, oh, no.
College and solutions. And it's like really in-depth questions.
Oh my god, I do nothing.
Like, do you know what has more like is it water?
I guess I can put the sugar. Happy birthday, introduce your license.
Interesting.
I've tested.
Holy crap, I'm out of breath.
Wait, you said you passed? I passed it.
Yay! And we were trying to like, my mom wanted me to drive over there. She's too busy and so my driver. They don't want to be my mom. Every time she's like, say Preston calls me up in the car with my friends. They were like, they were like, hi, Roxanne. And he's like, do you work today? I was I put this picture on my private story.
What's up, Mr.
And it looked like a
Where?
horse baby, but it's just because I strained my.
How are you?
The one at the mall. We drove to state.
I had a nosebleed 5 minutes ago, but other than that, I'm
Sweet.
good. Yeah.
Always fun to have in public.
She makes me jealous. That's the perfect. But I
Hey, I
scored.
better go,
Oh, and I scored PK.
Okay.
I was like coming back and coach, yeah, I was like, you could have done that a little more in the corner. I was like, it was like on the side and he was like, I'm kidding.
Did I leave the computer charger here? Have you gotten one?
I haven't seen one. You can check back there. A charger?
Yeah.
Yeah, nobody's brought it up here.
Okay, thank you.
Sorry, man.
Oh, yeah.
Nice. Yeah. They just started it.
Why they're already MVPs?
Oh, Mr. Hurley,
Hey.
I was thinking the other day, we should have Caroline, that girl that wants to transfer into math, can come in here one day that we're reviewing math tournament tests.
I think that would scare her off. Yeah.
Yeah. Well, tell her.
Oh, I will. I'll text her right now.
We might be doing something different tomorrow in class, so it's probably a good time.
Something different.
Yeah.
Different house.
Oh, no. Y'all need to get this ice cream. It's, oh, what's it called?
Hey, Mr. Hurley.